Hey young alchemist, today we are going into the realm of aromatics. We're going to start with three easy reactions: chlorination, bromination, and iodination. Before we start, let's look at benzene and its importance. Benzene is found in almost everything, commonly used as a starting material for making plastics, resins, synthetic fibers, rubber lubricants, dyes, detergents, drugs, and pesticides. We're going to start with chlorination. The conditions required for that are chlorine gas and iron chloride. Chlorine gas is toxic and can kill you. To generate chlorobenzene, iron chloride is a Lewis acid. You can also use other Lewis acids such as aluminum chloride and zinc chloride. Lewis acid are electron acceptors, which means they are deficient in electrons, and they need those electrons. Then you have bromination, which include bromine and iron bromide. First two reactions are catalytic, which means they're not consumed in the reaction. Third thing is iodination. It uses iodine and oxidant. An oxidant such as copper bromide or nitric acid and sulfuric acid. And it's stoichiometric, which means it is consumed in the reaction. It forms iodobenzene. Now let's talk about electrophilic aromatic substitution. Here you have a chlorine gas, which is electron rich, making it a nucleophile. And then you have iron chloride, which is a Lewis acid and a good electrophile, and it wants those electrons from the chlorine. So chlorine is going to directly attack. So the arrow is going to go from chlorine to iron, and you're going to form that intermediate. After that, step 2 is the attack of electrophile by the benzene ring. Benzene is a nucleophile. Its pi bonds are electron rich. So the attack is going to happen. You're going to form that. After that, deprotonation will take place. And then you're left with chlorobenzene, HCl, and iron chloride. Hey guys, for part 2, we're going to look at Friedel-Crafts reaction. Charles Friedel and James Kraft in 1877 came up with this reaction. If you want to alkylate a benzene, you use alkyl chloride and iron chloride. If you want to acetylate it, you have to use acyl chloride and iron chloride. Mechanism is same thing as before, electrophilic aromatic substitution, EAS. Step 1 is the activation of electrophile with Lewis acid. So here the Lewis acid is aluminum chloride. The chlorine on the acyl chloride is electron rich, so it's going to donate its electron pairs and forming this intermediate. Now, this chlorine is positively charged, so it's going to break that bond and form aluminum chloride, which is negatively charged, and then doing that, you're going to form a carbocation. In order to stabilize that, this is the best resonance form, which is known as a psyllium ion. So I'll write it down for you. Psyllium ion. So step 2 is attack of activated electrophile by aromatic ring, and this is the rate determining step. So in the benzene ring has a pi bond, which is electron rich, so it's going to attack directly on this carbon, and then it's going to shift that electrons onto the oxygen, making it stable since it's positively charged. After that, the third step is just deprotonation, where aluminum chloride just picks up that hydrogen and then you form that pi bond back, making it aromatic. So now you have this acylation on this benzene ring. Let's talk about other important reactions. First one is nitration. If you want to add a nitro group to the benzene, you have to use nitric acid and sulfuric acid. You can do the same thing and produce benzene sulfonic acid. Just use sulfur tridioxide and sulfuric acid. If you just want to revert that back and make that benzene again, you just do desulfonylation using sulfuric acid and heat. So now we have this nitro group. What next? Let's make that an amine, benzenamine. So to make that, we use reduction methods. There are two choices. Either use zinc and HCl or use palladium carbon hydrogen gas, which produces this benzenamine. After that, we can use this amine to form a diazonium salt. In order to do that, we use sodium nitrate and HCl, which gives this counter anion as chlorine, and or you can use Bose-Schumann reaction, so sodium nitrate and HBF4, which gives you the counter anion boron tetrafluoride. And after you add heat, you can get fluorine on the benzene ring. So basically a fluorination. For this one, you can use Sandmeyer reaction, copper chloride and copper bromide, which will add chlorine to it or bromine to it. And those are Sandmeyer reaction. You can also do copper nitrile, which is cyanation reaction, and form this nitrile. And this is a Sandmeyer reaction as well. With iodination and HBF4, you can add iodine or fluorine to it. Now, if I want to protect this, which is an amine, we just use acyl chloride or anhydride, base and pyridine, which is called Schotten-Bowman conditions. And you produce this, an amide. If I want to revert this back to an amine, I can just use sodium hydroxide and H2O, hydrolysis, and I can get this amine back. These are some of the important reactions for aromatic, and this could be useful in palladium chemistry, which is our next topic.